Hello students, welcome to Panda Power Education. Students, in the previous class, we already discussed equation of motion. That is, S is equal to ut plus half at square. Another equation, V is equal to u plus at. Another equation, v square minus u square is equal to 2as. Okay, so those three equations we already derived in the last class. In this class, we discuss graphical representation of motion. So why we go to graphical representation? Because we can derive those three equations by the help of graphical method also. Okay, so before going to derive graphical method in this equation, we have to know graphical representation of so many concepts. Then after getting that concept, then after we have to derive those equations in the help of graphical method. Okay, so let's proceed. Graphical representation of distance time graph. So now proceed graphical representation of distance versus time graph. So students, here there is two cases. Case in this graph we are arising case 1 and case 2. In case 1, a body is moving. In case 1, a body is moving. Body moving in a uniform speed. In a uniform speed. When a body is moving in uniform speed, then what will be the distance versus time graph? So now I will represent here. I will take time as x-axis. Here x-axis, that is y-axis. I am taking time as a x-axis and distance in y-axis. This is distance, D for distance, T for time. So it is in x-axis, this is y-axis, this is 0, this is 1. I think I will write 1 second, 2 second, 3 second, 4 second like this. Here 1 meter, 2 meter, 3 meter, 4 meter, 5 meter like this. So just see, when a body is traveling uniform speed, that means it will travel equal distance in equal interval of time. Then what will be the graph? If a body travel in 1 second in 1 meter, then in 2 second 2 meter, 3 second 3 meter like this. So this is equal distance in equal interval of time. Then the graph will like straight line. The graph is look like straight line. Clear or not? So if I take this is O, this is A, this one is B, this one is C. Clear? This is write down. Graph is look like straight line. Straight line. Okay. Clear or not? If we want to derive speed here, so we know that speed is equal to distance travel divided by time taken. So here just see how much distance travel. OB is equal to AC, that is AC divided by how much time? OA. Just see, this is AC divided by OA is equal to speed. So that is equal to slope of the graph. That is equal to slope of the graph. That means what we got it here? Here we got it. The slope of the distance versus time graph represent speed. Write down the slope of distance versus time graph represent what? Speed. Clear or not? This is the case 1. When a body is moving uniform speed, then the distance versus time graph represent straight line and the slope of the distance time graph represent speed. Clear or not? Next, case number 2. Case number 2. Write down case number 2. When a body is moving in non-uniform speed, write down non-uniform speed. When a body is moving non-uniform speed, then what is the distance time graph? Non-uniform speed means what? That means a body is travel unequal amount of distance in equal interval of time. That means if I take time is the x-axis and distance is the distance in y-axis, it is origin, it is 1 2 3 4 like this. This is 1 2 3 4 like this. Then it is a body, when body is traveling a non-uniform speed, then distance is unequal. Distance is unequal. What time is equal interval? Just see, in 1 second distance is travel 1 meter. In 2 seconds distance is travel 3 meter. Like this, in 3 seconds distance is travel 4 meter. Like this, 4.5 like this. So this is unequal distance, but equal interval of time. That means this graph is looking like what? Curved line. Graph is looking like curved line. Curved line, or this is called parabola. That means here a question is arises when a body is moving in non-uniform speed, the what will be the distance versus time graph? You have to written in your paper the distance versus time graph is in curved line when a body is moving in non-uniform speed. Clear? So this is the graph of distance versus time. Now we'll go to speed versus time or velocity versus time graph. Write down. Second, 2. Speed versus time, or same also velocity. It is same also, velocity versus time. Same thing. Clear? Here also so many cases. Case 1. First case 1. Write down. When speed of body remains constant. When speed of the body remains constant. That means when speed of the body remains constant, that means acceleration is 0. Acceleration is 0 at that time. So at that case, what is the graph of speed versus time or velocity versus time? So now I'll represent here a graphical representation. That is x-axis, that is y-axis. This is, I'll take x-axis as time, and this is speed or velocity. Same graph will come. Speed in y-axis. This is origin 0. This is 1 2 3 4 5 like this. This is 1 2 3 4 5 6 like this. Clear? This is in meter per second. This is in second. So just see, in I'm here writing speed of the body remains constant. That means the speed is never changes with respect to time. When time is increased, at that time speed never changes. That means speed is constant. That means at 1 second, if I'm taking speed is 5 meters per second or 4 meters per second, in 0 second also it is in 1 second 4 meters per second, in 2 second also 4 meters per second, in 3 second also. So that means speed is always remains constant by with respect to time. That means the graph is looking like this. Clear or not? That is right down here. This is constant speed. That is constant speed. Clear? So if I take here, this is time axis O, this one is A, this one is B, this one is C. Clear or not? If I just see, you have to write write down when a body is moving constant speed, when a body is moving constant speed, then it is straight line, then it represent straight line parallel to just see, straight line parallel to which axis? Time axis. Parallel to time axis in speed time graph. Clear? He is asking you a question. When a body is moving constant speed, what is the graph of speed versus time? So you have to write there. So the graph is straight line parallel to time axis. Clear or not? If you want to know the distance travel by the body, distance travel is equal to, we know that distance travel is equal to velocity v into t, velocity into time or speed into time. So speed into time or velocity like this, speed into time. So speed how much here, just see how much speed travel? Here speed is travel OC. OC is equal to AB. I can write instead of speed AB. Time how much? O to A, that is OA. So just see here AB into OA is the area of OABC rectangle. Write down here instead of AB into A, because this is length into breadth. So area of OABC rectangle. So if question is asking in distance time graph, in speed time graph, what is the distance travel? You have to write it is area covered total in speed time graph. Write down area covered in speed time graph represent what? Indicate what? Distance travel by the body. Clear or not? Total area represent distance travel by the body in speed time graph. Clear? So many type of short question here asking. Now case number 2. Case number 2. When speed, write down, when speed changes at a uniform speed. When speed changes at uniform acceleration or uniform rate. Uniform acceleration. Case number 2. That means uniform rate means speed equal amount of speed is changes with respect to time. So now I'll represent the graph speed versus time when speed changes uniform acceleration. Here I will take time as in x-axis and speed is y-axis. This is origin 1, 2, 3, 4, 5 like this. Here 1, 2, 3, 4, 5 like this. Clear? At time 0 second the speed is 0. At time in 1 second speed is 1 meter per second. At time 2 seconds speed is 2 meter per second. At time 3 seconds like this. So because equal amount of speed is in equal interval of time, that is called uniform acceleration. So now you can make the graph is like this. Clear or not? That is called uniform acceleration. Clear or not? Here sloping is upward. Right down. At that time body is in uniform acceleration. When sloping is in upward, at that time body is uniform acceleration in speed versus time graph. Clear? And slope of the graph represent acceleration. Slope, just I'll take O A B C. Here's the acceleration. Acceleration is equal to change in speed. Here how much? O to C. Speed is changing from 0% to C. That means OC is equal to AB divided by OA. Time is changed OA. Now this is called slope or not? This is slope of the graph. So write down slope of the graph. Which graph? Speed time graph represent uniform acceleration. Write down slope of the speed time graph represent uniform acceleration. Clear or not? Next, case number 3. Now write down when speed changes at uniform retardation. Retardation means negative acceleration. Retardation means negative acceleration. Now I will make the graph here. Speed versus time. Speed, here speed is y-axis, speed in y-axis, and that is y-axis. This is x-axis. Time I am taking time as x-axis. This is origin. This is 1, 2, 3, 4, 5 like this. 1, 2, 3, 4, 5 like this. So I'm taking here acceleration. Now if speed is 5 meter per second, in 0 second that speed is 5 meter per second. Now speed is decreases like this. That means slope is downward. Here slope is down. That is uniform retardation. Write down uniform retardation or negative acceleration, or slope is downward. Slope is downward. Write down. If slope is downward in speed time graph, then you can say that graph is represented as uniform retardation. That body is represented as uniform retardation. Clear or not? Write down. When slope is downward, then the body indicates what? Uniform retardation or negative acceleration. Uniform retardation or negative acceleration. Clear? Next case number, this is case 3. Next case number 4. Case number 4. When, write down, when initial speed, case number 4, when initial speed of a body is not 0. Initial speed is not 0. Then what will be the speed versus time graph? Write down. I'll here make speed versus time graph. That is time. I'll take x-axis as time, y-axis as speed. This is origin. This is 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 1 meter per second, 2 meter per second, 3 meters per second, 4 meter per second, 5 meter per second, 6 meter per second. So this is in y-axis. That means here is telling that speed is not 0 at initial speed. If I take initial speed as 2 meter per second at 0 second, initial speed is 2 meter per second. Like this, then speed is increasing like this. Now I'll make the graph. This is O, this is A, this is B, this is C. The graph is looking like this. This is uniform acceleration, but initial speed is not 0. Clear or not? So in this case, graph is looking like this trapezium type. It is looking like trapezium type. If I say that if we take how much distance travel, you already know distance is equal to average velocity into time. Average velocity or average speed into time. So here, what is the average speed? Average speed is initial velocity plus final velocity divided by 2. Initial velocity how much? OA, initial speed OA. Yes or no? OA is the initial speed. What is the final speed? BC. OA plus BC divided by 2. This is the formula of average velocity into what is the time is travel? OC. O to C is the time travel. This is OC. So just see what it represents, that value. This is the area of trapezium. What is the area of trapezium? This is the sum of the two parallel lines. Sum of the two parallel lines is OA plus OB divided by 2 into height OC. That is the area of trapezium. Area of trapezium OABC. So area of trapezium gives the distance traveled by body when the speed when the initial speed is not 0. That indicates area of trapezium of OABC. Clear or not? So now next case number 5. Write down case number 5. When last case, when speed is non-uniform means unequal amount of speed. A body travels unequal amount of speed with equal interval of time. Example, what is non-uniform speed? Where a body travel in high traffic. Okay, so in this case, I'll make the graph like this. This is time axis. This is speed axis. Y as a speed axis. x-axis I'll take time. So now this is origin 0, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 1 meter per second, 2 meter per second, 3 meter, 4, 5, 6, like this. Clear? So in 0 second, 1 second, what is 1 meter per second? In 2 second, 1.5. In 2 second, 1.5. In 3, this is 2. In 3 second, this is 4, like this. Now the graph is looking like this. Clear or not? So this is called curved line graph. Curved line. It is looking like curved line. In non-uniform speed. Non-uniform speed. Clear or not? Non-uniform speed. When, write down, when a body, write down, when a body travel in non-uniform speed, then it represents curved line graph, curved line in speed versus time graph, in speed versus time graph. Clear or not? So many short questions are asking in this chapter, graphical representation of motion. In this class we discuss so many concepts regarding speed versus time, or this is velocity versus time, or distance versus time graph. Okay, but next class we derive the equation of motion by graphical method, right? Graphical method, very important class. Next class is very important class. Okay, thank you.